go ahead and turn to wherever you took notes on even and odd. And go ahead and take a moment, kind of like we did on Friday, and just at your pod, kind of talk about what you wrote down. What did you understand from it? It's okay if you didn't understand it completely, but what did you understand from what you read and or wrote down? Okay, I'll give you about a minute to do that. Taylin, what was something that was mentioned at your guys' table? Okay. Was there anything, like, was there any piece that popped out to you as something that sounded familiar at all? Okay, the formulas look a little familiar. So there's a formula for each of them, right? Involving function notation. Okay, so even and odd each have some sort of formula to where we can algebraically show that it's true. We'll talk about those. And then there was another part of it. There was an algebraic piece, and then what was the other piece? Were there any pictures? Okay, Gracie, what did the pictures show? You drew the pictures, but you weren't sure what they were. Okay. Was the word symmetry thrown out at all? Okay. Read what you wrote down about symmetry. Okay. So one is symmetric to the origin and one is symmetric to the y-axis. So what we're going to go through and what I'm going to expect you to be able to do is take either an equation or a graph and determine if it is an even or an odd function. Not all functions are even and odd. A majority of functions are neither, okay? But a function is special if they have an even or an odd property, okay? Based on these definitions. So a lot of you wrote down, because I saw in your notes there, that an even function means that f of negative x equals f of x. F of negative x equals f of x. Okay? So we're saying that the function values are the same whether x is negative or positive. The function values are the same whether x is negative or positive. So that's going to create some symmetry, right? If our function values are the same, if x is negative 2 versus x is positive 2, our function values are the same. For x is negative 1, x is positive 1. We're going to create what kind of symmetry? If the function values are the same. Over what? Over the y-axis. Okay? So if you see a graph and there's symmetry about the y-axis, right? Here's the y-axis. If you can fold it along the y-axis and it looks the same, we have an even function. Our function values for x and negative x are the same all across. Okay. Some of you have started your 8 basic function chart. You didn't know how to fill out that last column of even and odd. Now you're going to be able to. Can somebody tell me one of our 8 basic functions that would be even? Because it's symmetric about the y-axis. Quadratic function. Y equals x squared would be an even function. What's another one? Absolute value function would be symmetric about the y-axis. Okay? So you can label those as even on your pink sheets. Okay? Probably another one. Yep, there's another one. What's another one you can fold on the y-axis?
is constant function.
Yeah, the one that looks like this, right? All the y values are the same. We can fold it along the y-axis, and it's the same on both sides. It would also be even. Okay. So on the flip side, we have an odd function. Okay. So an even function, there's its algebraic definition, and then with a picture. An odd function, its algebraic definition is that f of negative x equals negative f of x, which is going to create symmetry about the origin. Okay, so if you took notes from your reading, you probably have this written down. Okay, f of negative x equals negative f of x, and we have symmetry with respect to the origin. So here's the origin. Origin symmetry is going to mean that if we fold it along the x-axis and then fold it again along the y-axis, then it's going to match up. So we have some symmetry kind of on a diagonal, either like first and third quadrant or second and fourth quadrant, where they have that kind of diagonal symmetry. Okay. So let's just think about this definition right here. The function value of negative x is opposite the function value of x. So f of negative x, like if I pick a value like right here, f of negative x, has the opposite function value of x. Okay, so the x's are opposite, the y's are opposite. Okay, that's what that is saying. Origin symmetry. Which ones have origin symmetry on that 8 basic function chart? A cubic function is going to be an odd function. The reciprocal function is an odd function. It's symmetric about the origin. We don't know anything about the greatest integer. We'll talk about that tomorrow. So that's the only one you're not going to have filled out tomorrow. All the rest will be filled out. Identity function. This guy, right? The identity function is going to be an odd function. Okay? And then we have some functions that are neither. Right? Our square root function. There's no symmetry in the square root function, so it's neither. And that's okay. Okay, so what we did together really on that pink sheet, we talked about, based on the graphs, which ones were even and odd. That is something I'll expect you to be able to do. I'm also going to expect you to be able to take an algebraic definition and show me that it's even or odd. So we're going to do that twice. Okay? So go ahead and write down f of x equals 4x squared minus 2. Some of you can imagine what this looks like. Okay? And based on the picture, you might have a guess as to whether you think this is even or odd or neither. So if you have a guess, tell your neighbor. They'll hold you accountable. Okay? If you don't know, it's okay. Because we're going to do this algebraically anyway. Okay. So if we are even, then f of x equals f of negative x. If we are odd, f of negative x equals negative f of x. So really we have 3 things to compare. We already have f of x. We probably should figure out what f of negative x looks like. And then we would also want to see what negative f of x looks like. Okay? I would start with f of negative x because both even and odd are based on f of negative x. If you f of negative x. Function notation, we're taking negative x and we're throwing it in for x. When you're substituting, I would highly encourage you to use parentheses, especially when we have a negative value that we're plugging in. Okay. What happens to negative x, the quantity squared? It's an x, it's just positive x squared. So this becomes 4 positive x squared minus 2. Okay, well let's take a moment and let's think about an even function. Our algebraic definition was that f of x and f of negative x are the same. Is that true in this case? Are f of negative x and f of x the same? Everyone say yes or no real loud. Yes. Okay, so they equal, so we can stop. We know right now that this is an even function because we showed our work that f of x and f of negative x are the same. Okay. I'm not even going to worry about this over here because it's even, it's not going to be odd. Saves us some work. Okay?
So when did the negative x become positive?
When we square a negative, it goes away. Okay? If we were to cube it, it would have to stay negative. Okay. All right, so let's try this one more time. Let's try it with x squared minus x minus 6. Now, in our last example, some of you knew it was going to be even, but we still need to go through the algebra when I ask you to prove it algebraically. Okay? I'm not asking you to write a proof with words and all that stuff. Just do some algebra so we can tell that that's happening. Okay? Here again, we have a quadratic. Let's see if it's even or odd or neither. Okay? So, as I suggested last time, let's start with f of negative x because both definitions rely on it. Okay? At your pod, take a couple seconds and plug in negative x for me. Okay. So show me your work. Show me that you plugged in negative x, and then show me that you simplified it to x squared plus x minus 6. Okay, at this point we can determine whether this function is even. Is f of x the same as f of negative x? Okay, these are not. Okay, I want you to write that. I want you to write that f of x does not equal f of negative x. So I can see that you checked that it was even. Okay, so this means it's not even. Okay, I need to see your understanding through your work. Okay, so now let's look at negative f of x. Negative f of x just means we're taking a negative and we're applying it to the entire function. So we get negative x squared plus x plus 6. It changes all the signs. Okay. Now for an odd function, we need to determine if f of negative x is the same as negative f of x. So the two pieces of work that we've done here, do those come out to be the same thing? Oh, darn it. These are not the same, which means our function is not odd. That is okay. We can be neither. If our work shows us that it's not odd and that it's not even, then we're just a boring function. Okay? What's happening, okay, it was x squared minus x minus 6. We have a parabola and it has symmetry. It just doesn't have the symmetry that we want. Okay, here's the vertex right here. It's shifted over from the y-axis, so it's not symmetric about the y-axis. It's not symmetric about the origin. Okay? I really need to make sure that you are doing those homework problems tonight. Okay? Those are probably the most important from your homework this evening. Practicing on this algebraic, is it even, is it odd? Okay? All right, does this picture look familiar? We've had this picture before, okay? We are going to talk about relative minimums and maximums, and I'm going to show you how to do them in your calculator, okay? So relative minimum, relative maximum, okay? There are some coordinates that we can throw up here for relative minimums and relative maximums. Take 20 seconds, and at your pod, see if you can figure out which coordinates are relative minimums, which coordinates are relative maximums. What do you think? It's okay to be wrong. What do you think? Eli, what do you think is a relative minimum?
0, 3. Oh, minimum?
Yeah.
-3. 0, 3, -3.
This right here?
Yeah.
Okay. Sorry. Just trying to get on the same page as you. Okay. 3, -3. Does that seem like a minimum point? Okay. Is there another one? What is it?
-3, 0.
Okay. We can have multiple relative minimums because the relative means just in that general area. Okay. It doesn't have to be the absolute smallest point on the graph. It's just in that relative area. So what's happening is we are changing from decreasing to increasing. That's all that's required for us to have a relative minimum. We're in decreasing to increasing, we have a low point. Okay? Which means a relative maximum, we're going to be changing from increasing to decreasing. Okay? And which coordinate, Carly, does that occur at? 0, 3. Okay, so you're going to need to be able to identify that on a basic graph without your calculator, but then we also are going to learn how to use our calculators. So once you're done writing down whatever you need to, I need you to get out your graphing calculator and turn it on. Yes, you can borrow one for today. If you need to borrow one for today, please ask me. Okay. For today, or do you need to come out? Okay. 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 Okay, and just so I don't have to like go back and forth, go ahead and write down this function. I'm going to show you for today.
Yeah.
Okay. I'm going to show you how to type this in, but go ahead and write it down so that when I go to my calculator on the screen, you know what the heck we're working with. Okay. Okay, so f of x is x times x minus 2 times x plus 3. Don't write this down quite yet. Okay, we can come back to it when we need to. But I want to make sure we know how to use our calculator. So, first of all, is anybody borrowing theirs from an older sibling? Okay. Did she take stats? Okay, so we might have to do a couple things with your calculator, but it'll be okay. When we want to graph, you want to go into y equals. Okay, so everybody press y equals. Look up here. Do you see these plot 1, plot 2, plot 3? If any of those are highlighted, you're not going to be able to graph. Okay, so reckon this is what I'd be worried about with you. If any of those plot 1, plot 2, or 3 are highlighted, arrow up and hit enter to unhighlight them.
Does it matter if they're in radians or degrees?
Right now, no. When we get to trig, we'll have to be careful, but right now we're not going to worry about any of that. All right? Does everyone have a y equals? Okay. So now, do you see this button right here next to alpha? If you press it, it's going to be an X. Okay, that's the button I want you to use. So we need to type in X. Here are parentheses right here above the 8 and 9. Was it X minus 2? And then X plus 3. Did you write down that? So you type this in, and this is the X button, so press X, and then you try your first. Okay, and then what happens is when you hit graph, this should appear. Yes.
Oh, it's probably even how else it was last year. There's no proof of all the uses. Like, we choose it.
If yours doesn't look like mine with that 10 by 10, hit zoom 6.
Yeah, just like
Okay. If you ever are like having issues with it doesn't look like this button here, zoom. You can zoom in, zoom out, zoom square, blah, blah, blah. But if you go to zoom, 6 is standard. That'll always get you back to the 10 by 10 grid. Okay? All right, does everyone have this on their calculator? Okay, so up here, you have this button called trace, and right above it, it says calc. That's a calculate menu. So everybody press second, and then calculate. We're going to calculate a minimum. Okay. So you can either arrow down and hit enter, or you can just press the number 3, but we want a minimum. Okay. Each time you calculate something, it's going to ask you for a left and right bound. So, do you agree that this is a minimum right here? Okay, then you need to put the little blinky cursor somewhere to the left of it and hit enter. Then it's going to ask you for a right bound. So put your little blinky cursor somewhere within reason to the right of it. And hit enter. Then it's going to ask you, do you want to guess? Yes, I do want you to guess. So then you just have to press enter again, and it'll give you either a nice or not so nice coordinate for your minimum. Oh, you didn't mention. Okay. Okay. Go ahead and go to the second calculate menu and try that for the maximum. So you have to choose maximum this time and then go to the point right up here and see if you can calculate the maximum for me. So second trace is the calculate menu. Always press enter for guess. Yep. So if you want to make some notes like y equals put in function, second trace is the calculate menu, left and right bounds, okay? You can write down any little hints that you need to, okay? I'll give you about 1 minute, and then we're going to find the zeros with our calculator. Okay, please call me over if you have a question or you're having issues finding the maximum. When you're doing your homework, please pay attention to the instructions. It'll either tell you to use your calculator, or if it doesn't say anything about it, graphing utility is their word for it. If it does not say anything about a graphing utility, you're not using your calculator. So, probably if you didn't get quite to the left or quite to the right. So make sure you're to the left, very obviously. To the right, very obviously. So I don't think you go all the way over to the right. All right, now let's find a zero. Okay, when you go to your second calculate menu, do you see how it says 0? A 0 we talked about is a x-intercept. So you can do the same thing. It's going to ask for a left bound. It's going to ask for a right bound. It's going to ask for a guess. It's the same thing. You're just going to the left and to the right of an x-intercept. Okay. So you're going to get to practice both of those things in your homework tonight. Okay? Those of you, if your calculator is, like it hasn't arrived yet, maybe come to class 5 minutes early tomorrow, grab one of my calculators and finish your homework out. That would be fine. Yes? So second calculate, and you want to choose 0. And then on an x-intercept, it's going to ask you the same thing. Left down, right down, and yes. So you want to go to the left and to the right again, but intersect, or the intercept. Sorry. Okay, if you borrowed my calculator, please put it back. You have homework tonight, even and odd functions, minimum and maximums with and without a calculator. So please make sure you practice with the calculator when it says to. All right. Your pink sheets, 7 of the 8 rows need to be filled out by tomorrow. Okay, and tomorrow afternoon I'll put a key so you can check them. All right, we'll learn greatest integer function tomorrow. And then your quiz corrections, I guess reflections, your quiz reflections are due on Wednesday. Okay, so do whatever you need to do to get organized. That's what I need from you, all right? All right, happy Monday. We made it.
I have some questions about this because I was kind of confused on how to fill it out. Because I thought that, like,